Hi everyone, this is the 16th lecture in IE 451 Engineering Economy. And here's the very well-known cash flow analysis method, the present worth and the abbreviation is PW. And the rate of return annual cash flow and future worth. Okay. And chapter 5 talks about how to implement future worth technique, that is calculating a time zero equivalent value in various situations in selecting the best alternatives. And we will also talk about all these three later. And all of these evaluation methods will lead to the same result, of course. However, some economic analysis problems could be more easily solved by one of these techniques. And in chapter 5, most of the problems are focusing on the present worth method, present worth techniques. Okay. And like this screen shows, the present worth, the PW, is the value at time t equals 0, which is equivalent to the cash flow series of a proposed project. Okay. So the standard for a desirable, the present worth is very simple. If any alternatives has positive present worth, then that is desirable to do. And if any alternatives has negative present worth value, then those alternatives should be avoided if possible. And when you apply the present worth analysis, there could be three different analysis period situations. The first case is for each alternatives, the useful lives are equal to the analysis period. In that case, the analysis period can simply be the useful life of any devices considered, any alternatives considered. Okay? And for the second case, if the useful life of each alternatives are different from the analysis period, then there are two well-known methods for that. First method is to select an analysis period that is the least common multiple of useful lives from the alternatives. And the second method is the analysis period. So in that case, you need to estimate the terminal values of all the alternatives at the end of the analysis period. And the last case is about the infinite analysis period case. So if you think of the highways and dams and pipelines, for example, their lives are very close to perpetual. So the present worth of the cost analysis of this would have an infinite analysis period. Okay? So in that case, we're going to use special cost analysis, which is called the capital cost analysis. Okay, and the corresponding, the present worth is defined to the capitalized cost. Okay, so the capitalized cost is the present worth of the cost that are assumed to occur in perpetuity. And it can be computed by this formula. P equals A over I. Okay? So today we are going to solve a couple of end of chapter 5 problems based on these basic concepts. Okay? So the first problem that we are going to solve is problem 5-7. I'm sorry, 5-3. Compute the present value P for the following cash flows. So we've solved this type of cash flow diagram problems many times in chapter 4, right? So here, if you look at the period by period change amount, how much is that? It's positive $50, right? In chapter 4, we've learned about the arithmetic gradient series, where the cash flow has a uniform amount of change each period by period. So in that case, this given cash flow can be broken down into two components. One for an uniform annual series and another for an arithmetic gradient series. That's what we've done many times in the chapter 4, right? So we are solving problem 5-3. So we have two components here from 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And we have uniform series of $50, right? Let's say this present sum is equal to P sub 1. And what is left over here? If you take out $50 from this cash flow diagram, then you're going to have 50 at the end of period 2, and 100 at the end of period 3, and then 150 at the end of period 4. Okay? And let's set the present sum of money equal to P sub 2. Then this original P value can be obtained by summation of P sub 1 and P sub 2, right? So P equals P sub 1 plus P sub 2. P sub 1 is 50 times P given A. What is the interest rate? Is 10%. 10% over 4 periods plus 50 times P given G, and 10% over 4 periods. Okay? So we can get this table value. for 10%, you need to look at our text page number 613. P given A over 4 periods is 3.170. P given G is 4.378. 4.378. So how much is this? That's going to be 50 times 3.17 plus 4.378. That is $377.40. Okay, so this is the answer for problem 5-3. Okay, what about problem 5-4? Okay. Again, we need to compute the present value P for this cash flow diagram. So how do you compute the present value P in this case? There are several possible ways. And one of them would be $30 plus a uniform series of $20 for the next 2 periods, and then plus single amount of $30 at the end of period 3. Probably that will be the easiest one that you can go with. So here we have problem number 5-4. So the present value would be $30 at the end of period 0 plus the uniform series of $20 for the next 2 periods. So it's going to be 20 times P given A, 15%, that is the given interest rate, over 2 periods, right? And then the single amount of $30 at the end of period 3. So $30 times P given F, right? And 15% over 3 periods. And what about these vector values? If you look at our text page 615, you can get these values. P given A over 2 periods is 1.626. How about this? P given F over 3 periods is 0.6575. 0.6575. So how much is that? Okay, so this is going to be $82.25. Okay. So this is the answer for problem 5-4. And next problem is problem 5-2. Sorry, the sequence of the problem that we are solving has been messed up. So sometimes I go back to the previous page, and then sometimes I go back to the previous chapters as well. Okay. So please make sure you can mark it up on your text. Which problem we've been solved during the regular lecture, and which problem we didn't solve yet. Okay, that will be helpful for you to prepare for the midterm exam and the final exam later. Okay, so we are working on problem 5-2. Again, compute the present value P for the following cash flows. So in this case, if you look at the period by period change amount, how much is that? It's negative $100, right? So obviously this cash flow has a decline gradient, right? So this given cash flow can be broken into two components again. One for a uniform annual series of $300, and another for an arithmetic gradient series with G equals negative 100, right? So this is the problem 5-2. So we have two components here from 0 to 4. Right? And here we have uniform annual series of $300. So we have 300 down here. And let's set the present sum of money, P sub 1. Then what is left over here? We have negative cash flows, right? So at the end of period 2, we have negative 100, right? 200 minus 300 becomes negative 100. At the end of period 3, 100 minus 300, so we have negative 200. At the end of period 4, 0 minus 300 becomes negative 300. So like this, right? And let's say the present sum of money equal to P sub 2. And of course, this two diagram is exactly same as this. P1, 0, 1, 2, 3, 4. $300, right? These are exactly the same. And then instead of positive sign here, if we put negative sign, then we can have positive cash flow instead of negative cash flow, right? So here, piece of 2, 0, 1, 2, 3, 4. We have 100, 200, and 300. Right? So either is fine. You can go with, okay? So here, the present value, P, from the original cash flow can be obtained by summation of P1 plus P1 minus P2, or in this case, P1 plus P2, right? So if you want to go with the second cash flow diagrams, like this, it's going to be 300 times P given A, and 12% over how many periods? 4 periods minus 100 P given G, 12% over 4 periods, right? And so how much is that? It's going to be $498.50, I believe. Okay. What is the factor value first? 12% P given A over 4 periods, 3.037. P given G is 4.127. Okay? And also, if you look at this cash flow diagram carefully, you'll notice that even though this cash flow diagram includes the fourth period, it has the value of 0. So you don't need to include the fourth period here. Okay? So what I mean is this cash flow diagram can be broken into this from 0, 1, 2, 3. 0, 1, 2, 3. And uniform annual series of $300. And we set the present sum of money P1, we sign P1 prime. Okay? And the arithmetic gradient series of 100 in this case. So we have negative 100, negative 200. Okay? So in that case, G equals negative 100. Okay? And let's set the present sum of money equal to P2 prime. Okay? So this is better than the previous case, right? You don't need to include the fourth term. Okay? Because that information is redundant. Of course, this is exactly same as this, let's say this is the P1 double prime, 0, 1, 2, 3. Uniform series of $300. Then instead of positive sign, we have negative sign here. So instead of negative cash flow, we're going to have positive cash flow down here. So let's set this is the P2 double prime at the end of period 0. 1, 2, 3. So we have positive 100, positive 200. In that case, G is 100 instead of negative 100. Okay. And the original present value P can be obtained by summation of P1 double prime minus P2 double prime, right? Which is 300 times P given A, 12% over only 3 period, minus G 100 times P given G, 12% over 3 periods again. Okay. And here this vector value is P given A 2.402. And what about this? 2.221. Okay. So I believe the answer is same as before, which is $498.50. Okay. So as you can see, this problem, for a given cash flow diagram, you can get the present value using several different methodologies. Okay, several different ways. Okay, then next problem. How about problem 5-5? Again, find the value of Q so that the present value becomes 0, okay, in this cash flow diagram. Okay, so in this cash flow diagram, if the value of Q occurs 2 periods earlier, so let me redraw the cash flow diagram again. So problem number 5-5. Okay. So we have here 0, 1, 2, 3, 4, and 5. So we have uniform cash flows of $50. Okay. And interest rate is 12%. And we have Q right here at the end of period 1, right? So if the value of Q occurs 2 periods earlier, so that, let's say, in periods -1, at the end of -1, we have Q. So let's call this Q prime. At the end of period, -1. Then, in this case, we can use uniform series present worst formula, right, to compute Q prime value, right? So, in that case, how to get Q prime? In that case, a uniform series of $50, uniform series A equals 50, can be converted to an equivalent, the present sum, in this case, Q prime, by using the uniform series present worst formula. So Q prime equals 50 times P given A, right? 12% over how many years? -1 through 5 is 6 periods, right? So how much is that? 12% P given A over 6 periods, 4.111. This is the 4.111. And then this Q prime value will be converted to an equivalent future sum of Q by using the single payment compound amount formula. So in that case, Q equals Q prime times F given P, right? 12% over 2 periods. So how much is this? F given P over 2 periods, 1.254. And of course, these two steps can be combined into a single procedure. So if I rewrite down that, Q equals Q prime, which is this, right? 50 times P given A, 12% over 6 periods, times F given P, 12% over 2 periods, right? Then how much is this? We already got these factor values from the compound interest table. Okay, how much is that? It's $257.76. Okay, that is the value of Q in this cash flow diagram. Okay. Okay. And next problem that we are going to solve is problem 5-27. Again, we are required to compute the present value P for this cash flow diagram. So how would you compute the present value of P? this given cash flow diagram can be broken into two components. So here, let me redraw the cash flow diagram first. 0, because it's not very clear. 3, 4, 5, 6, 7, 8, 9. $50, $120, $50, $120, and then 50, 120. And we are using 10% of interest rate. Okay? So we have 3 50s and 3 120s, right? And this cash flow diagram can be broken into these two components. From 0 to 8, 0 to 9, 4, 5, 6, 7, 8, and 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? So here we can take out $50. We have 50s. Then what is left over? At the end of period 5, 7, and 9, we have 70s. Okay? So this is the P. Let's say the present sum here is equal to Q. The present sum here equal to R. Okay? Then P can be obtained by summation of Q and R, right? Okay, here. Then how do you get Q first? So if you set Q prime at the end of period 3, then a uniform series of $50 can be converted to an equivalent present sum of Q prime here by using the uniform series present worst formula. So here Q prime equals 50 times P given A, right? P given A, and 10% of interest rate over how many periods? 3 to 9 is 6 periods, right? And then this Q prime will be converted to an equivalent present sum of money Q. So Q equals Q prime times P given F 10% over 3 periods, right? And if you combine these two steps, Q equals 50 times P given A 10% over 6 periods times P given F 10% over 3 periods. Okay? This is about Q's. And what is this factor values for 10% interest rate? P given A over 6 periods, 4.355. P given F over 3 periods, 0.7513. So you can get the value of Q from this computation. Now, how to get the present value of R down here in the second diagram? How to get this value of R? You may think this cash flow is a series of 3 single payments, F. So we can compute the summation of present sum of R, right? So in that case, R would be the summation of these 3 future values, which is 70 times P given F 10% over 5 periods plus 70 times P given F 10% over 7 periods plus 70 times P given F 10% over 9 periods, right? So how much is that? P given F over 5 periods is 0.6209. 0.6209. What about this? P given F over 7 periods, 0.5132. And P given F over 9 periods, 0.4241. Okay. So here, the present value of P is the summation of Q and R, right? And from this formula, from this equation, we can get the value of Q. And from this, you can get the value of R. So P equals Q plus R. So how much is that? Okay, that is $272.67. Okay, that is the present value of P at the end of time period 0. Okay, $272.67. Or alternatively, you may set up here, this is the original cash flow diagram, right? Or alternatively, you may set up, let's say, P3 at the end of period 3. Then the P3 is the summation of the uniform series of 50s, and then the present sum of a series of 3 single payments of 70. So let me draw the cash flow diagram here to show you what it meant. Okay, so here we have from 3 to 9. 3, 4, 5, 6, 8, and 9, right? And then this cash flow diagram can be broken into these 2 parts. One for the uniform series of 50s, and then another for the series of 3 single payments of $70. Is that right? Okay. And then let's add, this is the P3 prime, and then P3 double prime. Okay? So in that case, this P3 is the summation of P3 prime, that is the present sum of uniform series of $50, and P3 double prime, that is the present sum of a series of 3 single payments of $70, right? And then once you get P3 value here, you need to convert it to the equivalent present sum of P. Okay? So you can do this way if you want. So in this case, let's get P3 prime first. P3 prime is the uniform series of $50. So P given A, 10% over 6 periods, right? And then how'd you get P3 double prime? P3 double prime is the series of 3 single payments of $70. So 70 times P given F, 10% over 2 periods, plus 70 times P given F, 10% over 4 periods, plus 70 times P given F, 10% over 6 periods. So in that case, P3 equals that case, the P3 equals P3 prime plus P3 double prime, right? So let me write down P3 equals P3 prime plus P3 double prime. Okay? And once you get P3, you need to convert it to the equivalent present sum of P. So here P equals P times P3, right? P equals P3 times P given F, right? And 10% over 3 periods. Then finally, you can get the value of P. So why don't you try to get the value from this alternative way? So let me just give you the table values for each of these vectors. P given A over 6 periods is 4.355, and P given F over 2 periods is 0.8264. What about this? P given F 0.6830. What about this? 0.5645. And what about this? P given F over 3 periods, 0.7513. Okay. Now you should be able to get the present sum of money, P, at the end of period 0. Okay, so how much did you get? It's $272.66. Okay. So compared to the previous method, there is only 1 cent difference, right? Which is negligible in this case. Okay, now let's solve problem 5-6. Use a geometric gradient formula to compute the present value P for this cash flow. Okay. So this is the gradient, geometric gradient series. So in chapter 4, you've learned about geometric gradient series. in which the cash flow has a constant or uniform rate of change each period, right? Then what is the period by period change amount in this case, in this cash flow diagram? 200 to 220, 220 to 242, 242 to 266.2. So let me redraw the diagram. Because it's not very clear to see the values. So we have 0, 1, 2, 3, and 4. 200. So something like this, okay? So here we have 200, 220, 242, 266.20, okay? And the interest rate we are going to use is 15%. So we want to know the present value, P, okay? So here the period by period change amount is, we have 20. And then here we have 22. And then here we have 24.2. Is that right? So the first difference, 20. 20 is 10% of 200, right? So 20 is 10% of 200. What about this 22? 22 is, again, 10% of 220. Is that correct? Likewise, the next value, 24.2, is again 10% of 242, and so on. So, what is the value of G? What is the constant growth rate per period? That is 10%. That is the constant growth rate, right? Constant amount of changes, which is 10%. So G is 10%, okay? And in this cash flow diagram, the cash flow amount at the end of period 1 is 200. So here 200 becomes a sub 1. Okay? The geometric gradient formula. Okay? So we have obtained these two values, G and A sub 1. And the given interest rate, I, is 15%, which is not equal to G. So we have to use the formula is 4 dash Okay, is formula 4-28 in our text, page number 126. Okay, you have to use the formula for 4-28 in our text, page number 126. For I is not equal to G, P equals A sub 1 times 1 minus 1 plus G to the power n, 1 plus I to the power negative n over I minus G. Okay? So here we know that A1 is 200, 1 minus 1 plus G is 10%, 0.1, N is 4 periods, right? From 0 to 4, right? Times 1 plus I is given as 15%, so is 0.15 to the power negative n, so negative 4 over I minus G, 0.15 minus 0.1. Okay? So what is this value? Okay, so this is the $651.60. Okay, that's the answer for problem number 5-6. Okay, the present value at the end of period 0 of this cash flow. Okay. Well, then I'm going to stop here for today. So next time we will continue to solve the end of chapter 5 problems. And I believe we are going to spend maybe 3 to 4 more hours for solving the end of chapter 5 problems. And then we're going to move on to the next chapter, chapter 6. Okay, thank you very much. Bye-bye.